Alright, so I did another video that was mixed Clayson, which happened with two ester groups that weren't the same. The regular Clayson happens with two ester groups that are exactly the same, identical. Now I'm on to Aldol. And just like before in the other chart, how I did the mechanism, and then I filled in the graph and then like showed you the quick how to do it. I'm going to do the same here. So the mechanism is that we find our alpha, that's step number one. You find an alpha by finding a carbon that's next to a double bond O, and the carbon that's next to the double bond O will have hydrogens. This is an alpha and this is an alpha. It doesn't matter which one you pick because they're exactly the same. Okay, so you find your alpha, you look over here and you go, oh, well, this one could be an alpha because that's a carbon next to a double bond O, but it already has 4 bonds, and so it's not the alpha because it doesn't have any hydrogens to work with there. So what happens is that this base comes and attacks the most acidic hydrogen there. This bond between the carbon and hydrogen gets broke. This free electron right there makes a bond here, so we have a double bond there. Carbon can't have 5 bonds, so it kicks this double bond to O, makes it a single double bond, or a single bond to O. This means that that's negative. This comes back down, and this double bond that was created, this electron right here moves to the carbon and makes the alpha carbon negative. So this double bond goes away. Now we have the alpha is negative, so this is the alpha, it's negative. And since we have an alpha, we know that it has to go to a beta. First step is you look for your alpha, you found it. The second step is after you found your alpha and you did your little thing to figure out that the alpha is negative, you got to go, oh, well, where does the alpha want to go? It wants to go to the beta. So it's like A to B, literally A to B. So your beta is the carbon that is attached to the double bond O, not next to like the alpha. It's attached to the double bond O. So this is now the beta. All right, now you got an alpha and a beta. Now the next step is, all right, the alpha attacks the beta. Okay, these electrons go up because carbon can't have 5 bonds. It's negative now. There's nothing to kick off, like in a later example. I'll run through that one real fast. There's nothing to kick off. So since this solvent that this reaction is taking place in has an acid, this right here, the O negative, since it can't come back down to make the double bond O again, comes and attacks the H of the acid. That makes water, and you have your product right here. Now notice that the A went to the B, the alpha went to the beta. Alpha here, alpha carbon, the alpha carbon has a C double bond O attached to it. C double bond O is attached to my alpha carbon, and the methyl group that's attached to the C of the double bond O there. The alpha is attached to the beta. There's the beta. You're good. It's that simple. A to B, alpha to beta. Now, here's the next example. Alpha, we found it because it has some H's here. First step, find your alpha. Find out where the alpha is going to attack. It's going to attack at the beta. Okay? Alpha gets attached to the beta. You made your alcohol there because the double bond could not be recreated. So the O negative went and picked up the H there. Yeah, just to clarify real fast, this beta carbon has an H. And that is, in fact, why the double bond couldn't come back down, because there were 4 bonds. And there's no ester group to kick off here, so the O remained negative, because you can't kick off carbons in this mixed aldol reaction. So the O was negative, it went and took an H away from the acid there. Again, alpha to beta. This is your alpha carbon. This carbon is next to a double bond O, but it already has 4 bonds. So there's no hydrogens there, it means it's not acidic, and that means that this is the alpha, alpha to beta. Alpha gets attached to the beta. There's your product. Alpha, alpha, beta, alpha goes to beta. Can't bring back the double bond, you put an H on. Same thing here. Now, next example is with this and this. The exact same thing happens. You're like, all right, well, this is a hydrogen and a hydrogen. Duh, there's no carbons to even make it an alpha, so you're like, all right, well then, since it can't be alpha, it must be a beta. It's like, you only got 2 choices. Alpha goes to beta. This is the beta. This is the alpha carbon here. You write your product. Same thing happens on down the list. Now, something different happens here now. Here we have a beta carbon, double bond O there, and we have this ester group. I mean, this is an ester, but you got this OR group that's attached to this carbon double bond O. This is an ester. Now, I'm going to show you a good way. Once you get really familiar with the mechanism, you don't sit there and like doing it like 50 million times. I'm going to show you something. Okay. So, okay. You write your benzene ring there. I got a beta. Alpha goes to beta. What's attached to my beta right now? This is a little trick that I just found out. Just write a single bond O. Okay? And you know that since the ester group has to leave, that there is going to be a double bond that you can create again. Because when this leaves here, when it leaves, there's 3 bonds there. So you can make your 4th bond with your alpha, because alpha always goes to beta. So what does my alpha look like? Okay, well my alpha looks like, or what does my alpha piece over there look like? So it goes like this, and you have a carbon there. So whenever you have something that you're not sure about, or if you want to just make a quick way of it, write a beta, write your alpha, attach the 2, but before, if you're not sure, because this ester looks unfamiliar, because over here we just had a formaldehyde and an aldehyde. There was no ester, there was nothing that was leaving. Here we have something that's leaving. So when you're done connecting your alpha to your beta, you know that carbon's got to have 4 bonds. So you know, oh, well, duh, I can make a double bond O here. Okay? Because before, when we were doing it, there was a single bond O there, and it was negative. And when you have an O negative, the electrons want to come back down to that carbon that it used to have a double bond O with. See up here, it used to have a double bond O. This is the beta. This is the beta. This used to have a double bond O. For this alpha to get attached to it, these electrons went up here, okay, so that it could have the 4th bond between the alpha and the beta there. Well, these electrons can't come back down. The only thing that can get kicked off is a OR group. And the reason is because O is really electronegative, and it's kind of happier on its own than a free radical like looking carbon. So because you can't bring those electrons back down, because carbon can't have 5 bonds, you're like, well crap, it's O negative, I must add an H there to make it neutral. I hope I'm making some sense. Alpha beta, for the next example, the ester group got kicked off, so you can make your double bond O. Same thing. Alpha beta, alpha goes to beta, write your alpha, everything that's attached to your alpha, you got your beta, write everything that's attached to your beta. Before this was a double bond to O, it was just a single. Well, I only got 3 bonds now. Should I put an H on here? No, I should not. Because I have another bond that has to be created to make 4. There's 1, 2, 3. Now I got 4. Alright. Same thing happens on down the list. Exact same thing happens with this group here. You get a double bond O. You get a double bond O back on your beta. Double bond O back on your beta. Double bond O back on your beta. Same thing. So this mirrors this, and this mirrors this. This column mirrors this column mirrors this column. Now, the next one, you have nothing leaving. So, you're okay. Since nothing's leaving, it's just like this over here. So this whole reaction, alpha goes to beta, write your alpha, write everything that's attached to it, write your beta, write everything that's attached to it, and then if you can make a double bond to O, go for it. If you can't, write an H. Same thing happens for every single one of these. First step, find your alpha. Second step, find your beta. Third step, write what's attached to your alpha, write what's attached to your beta. Connect the alpha and the beta. Do I make a double bond to O here or an alcohol? Well, I got 1, 2, 3, 4 bonds. If I write a double bond there, beta's going to have too many bonds, can't have 5, so I must write an H for O to be satisfied, and it becomes neutral. So, I hope that was enlightening to somebody. Alright, tune in for the next video.